Bismillahirrahmanirrahim. Hello everyone. So we're going to do practical number 4, PSI Blast. So for practical 4.1, we are going to use the PSI Blast, which is the position specific iteration blast. So compare the normal blast with this position specific iteration blast. If we use the normal blast, our result will only show the human database of the blast and also the non-redundant or RFSec databases. So if for example we are going to compare myoglobins, either beta globin or alpha globin of a human to a monkey or to chimpanzee whatsoever, we will not get the result. So we need to use this PSI Blast to find the distantly related proteins. So here we go. 4.1. First one, make sure it's blast P plus protein, and then just follow this instruction. Copy this accession number. Copy, I had already done it actually, and paste it here. And then this is actually not retinol binding protein. There's some typos there. It's actually hemoglobin subunit beta for human Homo sapien. So next, make sure we change this. So usually it's set to non-redundant protein sequence, but this time we use protein data bank because as we are comparing on the protein. And also make sure this program selection is PSI Blast, this one. And then we can actually enlarge the screen. It's too large. We can actually just push this plus button, but we can take a look at these parameters. Oh no. Take a look at these parameters. Expect threshold. Our expectation threshold is 10. This one is actually for the first iteration, and as we will run this PSI Blast for some numbers of iterations, maybe until 5 iterations. So the second iteration and third and fourth and so on will be using the PSI Blast. The first one use Blossom 62 scoring metrics. So as for the first iteration using Blossom 62 scoring metrics, the expect threshold is 10. Oh, it doesn't come out here. Expect threshold is 10, and therefore the second, third, and so on iterations we'll be using this PSI Blast scoring parameters. So the threshold will be set 0.005. So just click this blast. It's going into a new window. So here we'll get the results. We will have two things here. First one is sequence with e-value with better than threshold, which means it's making sense. I mean, like, it's related. And and then for the second one is sequence with e-value worse than threshold. So this seems to be unrelated to our query. So as you can see here, it makes sense as we are comparing hemoglobin subunit beta of Homo sapien with hemoglobin of Homo sapien, la la la. And also, I don't know, this one is Ratus novartis, maybe rat, I think so. So it means that we get to compare myoglobin of humans with rats. Oh, where is the rat? So take a look at all these numbers. You can see maybe, what is this? I don't know. Whatever is this? Isn't this cat? Sorry, I'm distracted. So it's actually stated that 84.03% similarity. This one is for the similarity part. So as we're comparing, our query sequence is for human myoglobin. So this one is for this, what is it? Phallus cactus. So if we see the sequence with E value worse than threshold, maybe like this, it's hemoglobin, still hemoglobin, but its percent identity is only like 26.61%. Oh, sorry. So even though it's still hemoglobin here, but its percent similarity is only 26.61%, so it seems far unrelated, right? So in order to get better results, we will run SciBlast for some numbers a couple of times. You can see this part. If we click this run, it will run the iteration for the second time. But take a look at this. If we select every sequences to be in the second iteration. So we just click run. It will take some time, so I'll just pause this thing. So here are the results, and we are getting more number of sequences with e-value better than threshold, which means it is being, our query sequence is being compared to this protein database more efficient lah. And also we are getting less number of sequences with e-value worse than threshold. Just now I think it's 13 something, so for now, for the second iteration, we only get 20 sequences selected. However, as you guys can see, these yellow things, means it's the newly added sequences, as we are getting more sequences of the e-value better than threshold, more from the iteration for first iteration. So this one is the newly added one. So in order to ensure it's we are on the right track, so we see all these things is still globin, and somehow we got this gene E, the haloperoxidase, but it's still, and it only got 18.7% similarity. So we just click here, in order to see is it related or is it not. So this one is showing its alignment actually. So just the alignment of our query sequence and this the last one, the haloperoxidase sequence. So we just click here. So look at the class, it's oxidoreductase, which means it has something to do with like myoglobin transporting oxygen. So it is still related, even though it has that very this less number of percent similarity. So we go back to our, this one is alignment, so we just click this one to get back here. So we have confirmed that this the haloperoxidase is still related. But if you find something not related after checking it, you can just deselect this. I mean, I don't want to deselect this, just for example, and run the third iteration. So just click this for the third iteration. So this is the result for the third iteration. As we can see, the sequences with E value better than threshold is increasing. Just now we got like 499 something, but for this time we get 500 sequences selected. And then we need to see also the sequences with E value lower than threshold. I don't think it's here, by the way. Just scrolling down. Oh, it's not here dah. Which means there's 500 sequences should be enough. But as to confirm, we can do the next iteration. Just click this run. So this is the result of the fourth iteration. As you can see, it's still the same result. Sequences with evaluated and threshold, we only get 500, and yeah, I don't think there is sequences with the E value lower than threshold. Yeah, this is for the fourth iteration. And just for another confirmation, we can rerun for the fifth time. And it already stated here, no new sequences were found above the 0.005 threshold. So it concludes the SciBlast practical position specified iteration. So some conclusion. What we have done is we are comparing this hemoglobin subunit beta with the related sequences, but it's distantly related, or for hemoglobin of Homo sapien with whatever they have in the database. It is this Dormeus, and whatsoever, to see is if our sequence is related or not. So that's all for the position specified iteration. 안녕.